Hello. Today I'm going to go over structure of the nuclear atom lecture. So we've been briefly talking about what an atom is, what it's composed of, and a little bit of the history of our current understanding. Modern science has refined earlier atomic theories by demonstrating that atoms are not indivisible units, but are actually composed of smaller components. So when we were first looking at atoms, we thought of an atom as the smallest bit of matter, like you couldn't break it down anymore. But then we found out, of course, you can keep breaking it down into smaller and smaller things. These fundamental building blocks are known as subatomic particles, which include electrons, protons, and neutrons. By breaking down the atom into these constituents, researchers have gained a deeper understanding of how matter is structured at its most basic level. So now we have this picture of the atom with electrons on the outside, neutrons and protons on the inside. This shift in perspective allows for a more accurate representation of chemical behavior and physical properties. So with this understanding, it tells us a little bit more about why atoms do the things that they do. Things like bonding or reacting. All right, so a little bit more of the history. In 1897, J.J. Thomson discovered electrons, which are subatomic particles that carry a negative charge. His research involved applying an electric current to low-pressure gases held within a sealed glass tube equipped with metal electrodes. That's what we see over here. We see the glass tube, and there's an electrode on each end, and then a current can be passed through this. By charging these disks, he produced a glowing cathode ray that moved from the negative electrode towards the positive one. So the important thing here is that we're getting a stream of some kind of charged particle. We know ahead of time that it's a negative, that it's electrons, but they didn't know this at the time. This landmark experiment fundamentally changed the scientific understanding of atomic structure by proving that atoms contain smaller charged components. So this was not an entire atom, it was parts of an atom. Again, the electrons, which we'll find out. J.J. Thomson's experiment with cathode rays led to the discovery of the electron as a fundamental component of all matter. By observing how these rays were deflected by magnetic fields, or by magnetic and electric fields, he determined they were composed of tiny negatively charged particles moving at high speeds. So you can see that in the picture. You can see this stream get deflected, and what you can't see is there's a magnet here. So it must be the positive end of the magnet because it's attracting the negatively charged electrons. Because the charge to mass ratio of these particles remained constant, regardless of the materials used, Thomson concluded that electrons are universal building blocks of every atom. So even doing this experiment with different materials, he was getting the same results, showing that electrons were in all of these atoms that he looked at. Building on this discovery, American physicist Robert Millikan successfully measured the specific quantity of charge held by a single electron. So now they know that there was charged particles up here, but now we're getting into more of the properties of those charged particles. For instance, putting a number on the charge of this electron. Using Millikan's charge value and Thomson's previously established ratio, scientists were finally able to calculate the exact mass of the particle. So they found the electric charge, and they found a mass. And you can see it says relative, so we'll get to that here in a second. These findings revealed that an electron carries 1 unit of negative charge and possesses a mass significantly smaller than that of a hydrogen atom. And what you see is that the proton and neutron both have a mass of 1. It's relative, so this is just it's not like a amount of grams or something like that. So they have a mass of 1. The electron has a mass 1/1800ths of that. And in some senses, you can think of electrons as having 0 mass. And then the charges, also, again, we're using plus ones and negative ones, because electrons and protons are going to have the same charge, just opposite. Atoms are naturally electrically neutral because they contain an equal balance of negative and positive charges. That's what we see over here. We see a positive proton and a negative electron. So -1 and +1 equals 0. So that's neutrally charged. When a lightweight hydrogen atom loses a negatively charged electron, this one, it leaves behind a particle with a single unit of positive charge, right there. These positively charged subatomic particles, known as protons, were first identified as canal rays traveling through a cathode ray tube. So these were still discovered using that same device that we saw over here. Obviously, the beam, if this all had been the same and these had been protons, would have deflected the other way, because this would have been the positive part of the magnet, and it would have deflected the positively charged protons. Modern physics recognizes that the nucleus also contains neutrons, which are neutral particles with nearly the same mass as a proton. So neutrons kind of came about later, the discovery. It was easier to figure out the protons and electrons. And then we realized that there's this neutrally charged particle as well. While protons are significantly heavier than electrons, both protons and neutrons are now understood to be composed of even smaller fundamental units called quarks. So we can break the protons and neutrons apart even into smaller subatomic particles. Together, these particles form the core structure of matter and dictate the unique properties of every element. Okay, this gets us started, but if you have questions, just let me know. Hope this helps. Thank you.